In episode 14, titled DHCP by Design, Scope Sizing, Resilience, and Failure Signals, we position Dynamic Host Configuration Protocol as foundational plumbing for client reachability because when it is wrong, everything above it looks broken. Many outages that appear to be the network is down are really clients cannot get valid configuration, and that configuration often starts with Dynamic Host Configuration Protocol. The exam treats this topic as both a design and troubleshooting domain because it touches addressing plans, segmentation boundaries, and operational resilience. When you can reason about scopes, leases, options, and relay behavior, you can interpret symptoms quickly and avoid blaming higher layers prematurely. Dynamic Host Configuration Protocol is also a service contract between infrastructure and clients, and like any contract, it needs capacity planning and clear failure handling. The goal is to make you comfortable designing it deliberately and recognizing its failure signals under pressure. Before we continue, a quick note. This audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Scopes, leases, and options form the service contract, and understanding that contract is more important than memorizing packet details. A scope is the defined pool of Internet Protocol addresses and related configuration that a Dynamic Host Configuration Protocol server can hand out to clients within a segment or a logical boundary. A lease is the time-bound assignment that gives a client an address for a period, which supports stability while allowing the pool to be reused as devices come and go. Options are the additional configuration values that clients need to function, such as the default gateway, domain name system servers, and other environment-specific parameters. When the contract is correct, clients obtain an address and the supporting information needed to reach resources. When the contract is wrong, clients may have an address but still be unable to resolve names or route beyond the local segment. This is why many failures present as connectivity issues, even when link and routing are healthy, because the client was given incorrect instructions. In exam scenarios, clues about wrong gateway or name resolution issues often point back to options, while clues about no address at all point to scope and lease behavior. Sizing scopes is capacity planning, and the most reliable method is to size for peak devices plus growth and reserves rather than sizing for an average day. Peak device count matters because Dynamic Host Configuration Protocol failures are often most visible when the network is busiest, such as shift changes, class changes, large meetings, or major events that bring many endpoints online at once. Growth matters because environments expand quietly, and a scope that is just barely adequate today can become exhausted after a few months of device additions, onboarding changes, or new Internet of Things deployments. Reserves matter because you want headroom for troubleshooting, temporary devices, replacement cycles, and unexpected spikes that you cannot predict. Scope sizing should also respect zone boundaries, because making a scope too large can blur segmentation and increase blast radius when an option is wrong. In exam reasoning, when a scenario describes intermittent inability to obtain addresses during busy periods, inadequate scope sizing is often a more plausible explanation than exotic routing faults. Lease time is a design lever, and it involves a trade-off between stability and quick recovery, which the exam expects you to recognize. Longer leases reduce lease churn, meaning fewer renewals and less Dynamic Host Configuration Protocol traffic, which can increase stability in environments with consistent endpoints. Longer leases can also help during transient server outages because clients can continue using their existing configuration for longer without needing renewal. Shorter leases help in environments where devices change frequently, where address pools are tight, or where you need misassigned addresses to clear quickly after a configuration mistake. Shorter leases also help recover capacity when many devices leave because addresses return to the pool sooner rather than remaining reserved for inactive clients. The risk is that too short leases can increase load and amplify the impact of server or relay instability because renewals become frequent and failures become visible sooner. In exam scenarios, when you see language about rapid turnover or tight pools, shorter leases often align with the need, while stable environments often benefit from longer leases. Redundancy approaches matter because dynamic host configuration protocol outages are disproportionately disruptive, and common approaches include split scopes or clustered servers depending on the environment's capabilities. Split scopes distribute portions of the same address pool across two servers so that if one fails, the other can still assign addresses, though with reduced capacity. Clustered or highly available server designs provide more seamless failover behavior, but they introduce additional complexity and require careful configuration consistency. Redundancy is not only about servers, it is also about network reachability to those servers, because if clients cannot reach the service due to a relay or routing issue, redundant servers do not help. The exam often tests whether you think about failure domains because a single relay failure or a single boundary failure can isolate many clients from dynamic host configuration protocol even if the servers are healthy. A good design chooses redundancy that matches operational maturity while ensuring that failure does not concentrate at one fragile point. The best answer usually includes both sufficient capacity and an availability approach appropriate to the scenario's constraints. Relay behavior becomes important when clients and servers sit on different networks because dynamic host configuration protocol discovery is local by default and needs assistance to cross-routed boundaries. In a segmented environment, you often place dynamic host configuration protocol servers in a controlled infrastructure zone while clients reside in many separate subnets. The relay agent listens for client broadcast requests on a subnet and forwards them as unicast to the configured server, then relays responses back to the client. This forwarding relies on correct configuration, correct routing, and correct security policy, because a relay is effectively a bridge for a foundational service. When relays are misconfigured, clients may fail to obtain addresses even though the server is functioning, and the symptom can appear as a localized outage affecting one segment or one virtual local area network. In exam queues, when only one subnet or one building cannot obtain leases while others are fine, relay misconfiguration or relay reachability is often the most direct explanation. Understanding relay behavior helps you avoid assuming the server is down when the real break is at the boundary. Dynamic host configuration protocol also introduces a security risk through rogue servers, and limiting that risk is part of designing the service responsibly. A rogue server can hand out incorrect gateway and domain name system options, redirecting clients to malicious paths or causing denial of service by providing unusable configurations. Rogue behavior can be malicious or accidental, such as a misconfigured device acting as a server on a segment where it should not. Limiting this risk typically involves ensuring that only authorized servers and relays can provide dynamic host configuration protocol responses, and that the network enforces this at the segment level. The practical point is that the risk is amplified because clients generally trust the service automatically, making it an attractive target for attacks and a common cause of confusing outages. In exam scenarios, if clients suddenly receive wrong gateway information or are redirected to unfamiliar resolvers, rogue dynamic host configuration protocol should be in your threat model. A design-aware answer considers both functionality and the risk of unauthorized configuration sources. Failure signals are one of the most testable parts of this topic, and you should be able to recognize symptoms of scope exhaustion, wrong gateway, or wrong domain name system quickly. Scope exhaustion often appears as clients failing to obtain an address during busy times, or as clients self-assigning an address because no lease could be obtained. Wrong gateway often appears as clients being able to reach local resources but failing to reach other networks or the internet, which can be misread as a routing outage when the real issue is a bad option. Wrong domain name system often appears as clients being able to connect by Internet Protocol address but failing to resolve names, which can masquerade as the application is down when the network is fine. These symptoms are powerful because they point to different parts of the service contract, and the fastest troubleshooting comes from matching the symptom to scope, lease, or options. The exam often provides just enough detail to let you make this match, and the correct answer usually aligns with the simplest contract element that explains the behavior. When you train your ear for these signals, you become faster at eliminating distractor answers that propose complex fixes for basic configuration failures. A short example can make lease behavior concrete, such as phones failing after a lease renewal window, because it illustrates how timing patterns reveal the cause. Imagine a set of devices that work fine after boot and then start failing around the same time later in the day, especially after a known renewal interval. If the devices attempt to renew and cannot reach the dynamic host configuration protocol server or relay, they may eventually lose valid configuration or fall back to self-assigned behavior, depending on client rules. If the server responds but provides incorrect options due to a misapplied scope or misconfigured option set, the devices may renew successfully but then lose connectivity because their gateway or domain name system settings changed. The key in this example is that the timing correlates with lease behavior, which is a strong clue that the issue is in address assignment or option delivery rather than in application stability. In exam scenarios, time-based patterns like every few hours or after lunch are often hints about lease renewal and scope behavior. Recognizing that pattern helps you choose answers that focus on the dynamic host configuration protocol contract rather than on unrelated layers. A pitfall in capacity planning is forgetting reservations and static addresses because those consume space and can create hidden constraints within a scope. Reservations tie a specific client identifier to a specific address, which is useful for stability, but it reduces the flexible pool if you do not account for it. Static addresses assigned outside dynamic host configuration protocol can also collide with the pool if ranges are not carefully planned, leading to intermittent conflicts that look like random outages. Capacity plans that assume the entire scope is available for dynamic assignment will be wrong if a meaningful portion is reserved or used statically. This is especially risky in environments with printers, servers, cameras, or specialized devices that are often given stable addresses for convenience. In exam reasoning, if a scenario mentions many reservations, many infrastructure devices, or a history of address conflicts, ignoring these factors is likely to lead to the wrong conclusion. A good design includes clear separation between dynamic pools, reserved ranges, and static allocations so conflicts are less likely. Another pitfall is mismatched virtual local area network assignment causing wrong scope use, because if a client lands in the wrong segment, it receives the wrong contract. This can happen due to misconfigured switch ports, incorrect trunk settings, wireless network mapping errors, or endpoint authentication policies that place devices into unexpected zones. When a client receives an address from the wrong scope, it may have a valid lease but invalid network context, such as a gateway that does not reach the intended resources or domain name system servers that are not appropriate for the device's role. The symptom can be confusing because the client has an address and can talk locally, yet it cannot reach the services it needs, and only some devices may be affected based on which ports or access points they use. In exam scenarios, wording like "only one floor" or "only devices on a certain wireless network" often points toward a segmentation issue rather than a dynamic host configuration protocol server failure. The best answer usually involves ensuring correct virtual local area network placement and correct scope mapping through relay and policy rather than simply increasing scope size. A helpful memory anchor is scope, lease, options, relay, resilience, because it captures the main moving parts you need to check in both design and troubleshooting. Scope reminds you to plan capacity and boundaries, and to verify pools and exclusions align with zone intent. Lease reminds you to consider time-based behavior, churn, and recovery patterns, especially when symptoms appear on a schedule. Options remind you that having an address is not enough because gateway and domain name system settings determine real reachability. Relay reminds you that segmented networks need correct forwarding behavior and that failures can be localized to one subnet even when servers are healthy. Resilience reminds you to avoid single points of failure, whether that is a single server, a single relay path, or a single boundary link. When you can recite this anchor, you can structure your reasoning quickly without missing the common failure points. To end the core with a diagnostic prompt, consider a client that self-assigns an address, which is often the clearest signal that it failed to obtain a valid lease. Self-assignment typically means the client could not reach a dynamic host configuration protocol server or relay, or that no addresses were available in the scope when the request was made. In a segmented environment, the most likely culprits include a relay misconfiguration, a blocked path between relay and server, or a scope that is exhausted during peak. If the issue affects only one subnet, relay behavior and segment placement rise in priority, while if it affects many subnets, server availability or upstream policy is more likely. This is also where timing matters, because self-assignment after a lease renewal window suggests renewal failures rather than initial boot failures. The best exam answer in this case usually focuses on verifying the service contract path, meaning scope, capacity, relay forwarding, and policy allowing the required traffic, rather than blaming applications or domain name system. When you recognize the self-assignment symptom, you can narrow your decision quickly. In the conclusion of Episode 14, titled DHCP by Design, Scope Sizing, Resilience, and Failure Signals, the design steps are about making client configuration predictable, scalable, and resilient, so reachability failures are rare and easy to diagnose when they occur. You treat scopes, leases, and options as a service contract. Size scopes for peak devices with growth and reserves, and choose lease times that balance stability with recovery needs. You build resilience through split scopes or clustered servers and ensure relay behavior is correct across segmented networks because relays are often where localized failures begin. You reduce security risk by limiting rogue dynamic host configuration protocol behavior and by keeping segmentation and policy consistent with how clients are placed. You watch for failure signals like scope exhaustion, wrong gateway, wrong domain name system, and self-assigned addresses. And you avoid pitfalls like ignoring reservations in capacity plans and mismatched virtual local area network placement causing wrong scope use. Assign yourself one scope planning rehearsal by choosing a zone, estimating peak devices and growth, deciding a lease strategy, and then stating which options must be correct for that zone so the contract remains clear and reliable. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.